Today we're going to be identifying angle relationships when parallel lines are cut by a transversal. One of the first relationships we're going to look at are vertical angles. Here we have a set of parallel lines that will not intersect, and this line that intersects both of these lines is our transversal. All right, what we mean by vertical angles, we take a look at each intersection. Here we have two intersections. First intersection 1, 2, 3, 4. Next intersection we have angles 5, 6, 7, and 8. So in our first intersection here, vertical angles are angles that sit across from each other. So angle 1 and angle 4 both sit across from each other, and these are what we call vertical angles. Also, another thing you will notice that angle 1 and angle 4 looks like they are the same angle, which means angle 1 is going to be congruent to angle 4 or have the same measure as angle 4. In the same token, take a look at angles 2 and 3. These also sit across from each other, and you also may notice that the openings are very much identical. So it means angle 2 is congruent to angle 3. Now moving to the next intersection, we'll notice angles 5 and 8. These two angles sit across from each other. So angle 5 is congruent to angle 8. And also in that same intersection, we take notice of angle 6 and angle 7. These two angles sit across from each other. So angle 6 will be congruent to angle 7. So these two will have the same measure. All right. Our next set of angles are the corresponding angles. Again, we take a look at both intersections here. Another word for corresponding is matching. In this case, we look at each intersection. We're looking for which angles are in the exact same position. So we take a look here. Angle 1 and angle 5 are in the same positions in their respective intersections. So angle 1 and angle 5 will be corresponding. And since these are parallel lines, you also take notice that the openings of angle 1 and angle 5 are very much identical. So angle 1 is congruent to angle 5. So we also see corresponding angles are congruent or have equal measure. All right. In the same token, we take a look at angle 2 in this intersection matches angle 6. These two are in the same position in their respective intersections. So angle 2 is congruent to angle 6. And we continue, angle 3 and angle 7, they're in the same position in their intersections. So angle 3 is congruent to angle 7. And last but not least, take a look at angle 4 and angle 8. These two are in the same positions in their respective intersections. So these two will also be congruent or have equal measure. All right, now let's move forward and take a look at alternate interior angles. All right, since we're talking about interior, that means we're looking at the inside of our two parallel lines. So here, on the inside of these two lines, is what we call the interior, the inside. All right, and on the inside of these two lines, we notice we have angles 3, 4, 5, and 6. And to alternate, this means we're going to be switching sides. So angle 3 and angle 6 will alternate. Kind of similar to how your vertical angles were sitting across from each other in the same intersection. But here we don't quite have the intersection, but we have our transversal. So we look at them in a similar way, alternate interior. So angle 3, if we look at across that in this manner, angle 3 and angle 6 will be considered alternate interior angles. And also if you take a notice of the openings of angle 3 and angle 6, they're very much identical. So angle 3 will be congruent with angle 6, which also means alternate interior angles are congruent too. And then also in the same manner, angle 4 and angle 5 are also alternate interior. Angle 4 will be congruent to angle 5, and these two will have equal measure. All right. Now, last set of angles, we talked about interior. Now let's talk about exterior. All right. Alternate exterior angles. All right. If we take a look at exterior, this means, in short, the outside. So we're looking outside the two parallel lines for exterior angles. In our first intersection, angles 1 and 2 are on the outside of our top line here. So these will be exterior angles. And then in the next intersection, the exterior angles here will be 7 and 8. These are exterior angles. And so we look at our alternate exterior angles the same way we do our alternate interior angles. In the same way we look at our alternate interior angles, same way we look at our vertical angles, which will be sitting across from each other on the outside. So here we see angle 1 and angle 8. And you pay attention to their openings here, that the openings are very much identical. And so angle 1 is also congruent to angle 8. So that means alternate exterior angles also produce congruent angles, or angles with the same measure. And our next set of exterior angles, we have angle 2 and angle 7. They will be sitting across each other on the outside. So angle 2 is also congruent to angle 7. And these are alternate exterior angles. So in short, we have 4 different relationships here. We have our vertical angles. We take a look at one intersection at a time and look at which angles sit across from each other. Corresponding angles, looking at each intersection for which angles are in the same position in each intersection. Alternate interior angles look on the inside of our two parallel lines, which angles sit across from each other on the inside. And last but not least, alternate exterior angles we look at our angles outside the parallel lines that sit across each other on the outside. So there you have it. That's how we identify angle relationships when they're cut, when parallel lines are cut by a transversal.